bulk handling, to a certain extent, is more difficult than containers because the product is less standardized. But containers require larger accuracy. And again, let's see where our sensor component comes from. Why are not all container terminals automatic today? And the main reason is we are not there from a sensor perspective. LiDAR development isn't funded by port automation. It isn't funded by companies like iSAM, and it can't be funded by companies like HHLA. It's funded by the automotive industry for self-driving cars. And they are investing billions of dollars in that technology to make it better. And what we have seen in the last years is that we gained high resolution. That means up to 256 parallel scan lines, that we have a 200-meter range in low visibility conditions, and that we are also moving to inherently safe sensor designs. Because obviously, when you do self-driving cars, you must prove that your sensor is able to see the kid that is appearing behind a parked car. So what we do, we benefit on billion-dollar development that is put from the automotive industry into the LiDAR sector. I told you that we need about 0.5 meter of accuracy on a moving target for bulk handling. For containers, this is slightly different. We have 3 levels of accuracy, and the first one is what I call flipper. Flipper means we have mechanical guidance, and we are able to pick up or set down a container with the help of a mechanical funnel. That means we need about a 10 centimeter accuracy, and we are working on stationary targets. And this is what CTA, Container Terminal Altenwerder, has been doing since 2000 by putting containers automatically on AGVs. The next step, which is about a 5-time increase in accuracy, and that was only possible recently, is to put a twist lock to put a corner casting exactly on a twist lock or a pin. That means we need 2 centimeter accuracy, but we are still on a stationary target. And this is what we have done at Altenwerder in 2020, and I'll show a couple of videos on how that looks in real life soon. The last step, which we are targeting for 2025, is to be able to do 2 centimeter accuracy on a dynamic target. And that will finally open the solution to handle containers on a moving vessel. I'm not meaning a dynamic target like a fast car or something like that, but the vessel is moving a couple of decimeters every 5 or 6 seconds, roughly, in the waves. And we have to be able to compensate that vessel movement if we want to do containers on a moving vessel. So summary, where we are now, we are currently in the industry at flipper accuracy, 10 centimeter on stationary. At Altenwerder, as a first port in the world, we are at twist lock accuracy with stationary targets. And where we plan to go is twist lock accuracy on a dynamic target, finally enabling automatic ship-to-shore cranes. Our blueprint for autonomous container handling was Rail Crane 4 at Altenwerder. And it's the first system which is able to set a container on a rail car, and just by using the corner castings to put it on guidance pins. Many of you know other terminals, especially in North America, which operate already automatic rail cars. The big difference is that in America, you have mechanical funnels on rail cars, and in Europe, you don't. So that's the difference, again, between the 10 centimeter and the 2 centimeter accuracy that we found. Second, what we want to do, we want to be able to run all type of ISO containers, including tank containers. That means the only object we are allowed to use on a container is the corner casting. And the target is that finally, in the autonomous rail yard, people working there, like rail operators, mechanics, checkers, that are the engineers who run around and check that the containers are looking good, that they all can work collaboratively with the autonomous cranes. And our target, and we are 110% sure that we will achieve that, is that one operator will be able to handle 4 rail cranes, including the exception handling, from one control station. I've personally run this crane for now about 20, 30 shifts. And normally in a single shift, we have only 1 or 2 exceptions that we need to handle. And we have now moved about 2,500 containers without a single incident and without the need to reseat a single container. So how does that look in real life? I've prepared something, a small video for you. And that will show a couple of typical situations. But first, let me show you the LiDAR sensor. The LiDAR sensor is under the operator cabin. It's a single sensor that gives us a full view of the container, the spreader, the corner castings, and the rail car. And I've highlighted the interesting points with these yellow circles. And you will find these yellow circles also now in the real moves. So let's do the first one. The first one's a pickup. We want to put a spreader on a container. You see with the reflector, and the reflector is used by the scanner to identify the spreader. And we just put it down on the container. There's absolutely no horizontal movement once the down movement has started. And that is very important from a safety perspective, because it can't happen that the person standing next to the container will be hit by sway of the container. Obviously, this is now a bit high speed. I only want to show you the interesting parts. We have picked it up from the train. We move it now to a terminal truck. Again, our only orientation point is the lower corner casting and the funnel at the end of the terminal truck. That means even a container which is not loaded properly, which has an off center of gravity, which has slightly moved behind the spreader, because we are just looking at the corner casting. So we can put that with the same level of precision on a terminal truck as a skilled operator can. This is a video which I took standing nearby, and it shows you the level of precision. Basically, you want to bring it on that sloped surface so that the container is slightly gliding on the terminal truck, so that in the end, it's at the very back of the truck. And that's exactly what the operator is doing and what we are replicating using advanced laser scan technology. Of course, the key purpose of the rail crane was to put a container on a rail car. And this has a lot of very interesting markers on that scan image. The first one are, of course, the pins. That's the red dots that you see there. And next to the pins, we have this green and a red rectangle. And that basically tells us that on the left, we are all clear. We don't have to be careful there. On the right, there's another container. And you will see later on a video where I'm putting a container exactly between two others, which is even more challenging than what we have seen here. But we have done that now a couple of thousand times, and every time the operator sitting on the crane say, well, we can't do it with this precision. You see it here, it's about a 1 or 2 centimeter that we precisely are able to put a corner casting on a pin. And this is really a world first. This video has not been shown outside of HHLA so far. Handling containers precisely is not the only challenge that you have. You also have to confirm that the rail car is prepared properly. Basically, that means that there is no additional pin in use, and that would damage the container when you put it down. So our system is not only able to identify the 4 pins that we need, it's also able to identify additional pins which shouldn't be there and warn the remote operator before it sets down a container on them. And this video is a bit for bragging rights again. We are putting a container between 2 other containers without any horizontal movement. We're just pre-positioning. We are setting it down, and the laser scanner is guiding it with centimeter level precision between the 2 containers. We are slightly slowing down at that point. We don't have to do that technically, but it's more or less, well, the operators are already wondering when this will crash for the first time. It hasn't so far. And we are just slowing down a bit just in case we still are not 100% perfect at what we are doing here. We also have unusual situations in the terminal, like a terminal truck that wasn't parked properly. I think you can see that this truck wasn't maybe parked at night and it's not properly aligned in its parking spot. And what we can do with the automation, we see this terminal truck, we properly align the container without any intervention of a remote operator. Nothing what you see here is a remote operator. That's all fully autonomous. We properly align the container, we set it down, and well, the outcome is as good as what a human operator can do. By the way, the guy there in the small car, that's what we call the checker. He's inspecting the containers. And we have GPS receivers on the check mobiles, the cars which they are driving around, to make sure that we don't move suspended loads over one of these check operators. Last but not least, we can also handle every type of non-standard, non-box shaped containers as long as it has ISO corner castings. So 10 containers can be handled, 10 containers which have slightly overlapping ends, the 30 footers, all this can be fully done autonomously. And that is the reason why we believe so that one operator will be able to do 4, 6, or 8 rake cranes in the future with this technology. What takes us this? We are now in end of 2021, and we want to go through full certification of the autonomous crane in 2022, and we do that together with DNV, and we are on a very good track for it. Then in 2023, we want to roll this out over the intermodal container cranes and basically leverage this 2 centimeter accuracy on the stationary targets. 2024 to 2025, with the new container cranes arriving at Altenwerder, we will be preparing for a semi-autonomous operation of the crane, which means we are fully autonomous on the land side, but we need augmented reality and remote control on the water side. When in 2025, what we all expect, solid-state LiDAR will drop down from the automotive industry to our world, we will be able to get 2 centimeter accuracy on a moving target. And that means we can start with waterside pickup of containers. That will get us to a point where one operator will be able to handle about 2 to 3 of these ship-to-shore cranes. And finally, and I'm very confident that this is technically a realistic target, 2027 to 2028, we will be able to do fully autonomous pickup and set down on the water side.